Hello students, today we are going to discuss chapter number 4, that is motion. Already you know that a body can be in two states. One is rest and another one is motion. A body is said to be at rest when its position does not change with time with respect to the observer. It is very important because if you take a car and after a time its position does not changes, means after a little while also it will be staying here only, then its position does not change, then we will say that the car A is at rest. And about the motion, likewise a body is said to be in motion when its position changes with time with respect to the observer. Let us take another car. Let this car, when an observer starts looking at it, then after time t, this car moves and reaches to a point somewhere here. Then we will say that the car is moving and it moved from B to a point C. So here we have a live example. This ant is changing its position with respect to time, and this camera is observing that ant. So it's changing its position. That means the ant is in motion. Don't know where it went off. It is necessary to take a reference point or an observer because let us take an example. If a observer is standing near a tree, then according to him the tree is at rest. And if a car pass by the observer, then he will say that the car is in motion. But the person sitting inside the car, if he is the observer, then according to that person who is sitting inside the car, will notice that the car, the seat of the car all are in rest. But when he will look outside the window, he will see that the person, the tree or any buildings all are in motion, all are moving. That means a body is at rest or in motion depends not just on the body but also on the state of the observer. So we can conclude that rest and motion are relative terms. So the state of rest or motion will depend upon the observer from where the motion is being observed. If the observer is at rest, then the other objects which are changing its position with respect to time will be in motion. But if the observer is already in motion, then according to him all the other things which is not moving with him will be considered for him it will be considered as in motion. But the car, the vehicle in which the observer is moving, it will be in rest with respect to that moving observer. Next topic is our point object. Point object. Any object can be referred as point object if the distance traveled by the object is much greater than its own size. For example, a football in a football ground, a train which is moving from Raipur to Delhi. In all these cases, the object which is traveling is much smaller as compared to its travel distance. Next, we will discuss scalar and vector quantities. First one is the scalar. Scalar quantity, the physical quantities which have only magnitudes. Only magnitudes, no directions. Are called scalar quantities. For example, we can take kg, meter. Second one is the vector quantity. Vector quantity, the physical quantity which has magnitude as well as direction. Is known as vector quantity. For example, 5 kilometers towards east. So 5 kilometers towards east, or I can say if it is a scalar quantity, we can say just 5 kilometers. Then this 5 kilometer is just giving the sense of magnitude. Magnitude is the quantity, so it is how much kilometers, we can say 5 kilometers, but in which direction we don't know. But if it is a vector quantity, we will state as 5 kilometers towards east, towards forward, backwards, anywhere we can take it. For here we are taking 5 kilometers towards east, so 5 kilometers towards it gives the magnitude as well as the direction. Vector and scalar quantities are important because sometimes we just need the magnitude, but sometimes it is necessary to have a sense of direction. For example, if someone will ask me from a point that I want to go to Bhilai, then if I will say just only 22 kilometers, if I will say just 22 kilometers from Raipur, they will reach anywhere. But if I will give the direction as well, like 22 kilometers towards west, then if they will start from Raipur and they will travel 22 kilometers towards west, they will definitely reach their destination. Now let us discuss about distance and displacement. Distance, the actual length of path covered by a moving object between its initial and final position. If I will take an example, if an object starts from a point A, it travels 2 kilometers, then from there it comes to another point which is about 4 kilometers, and then to its final destination, let it be this point, which is also 4 kilometers. Then the distance traveled by that object will be the total length of the path, that means from this to this, it is 2 kilometers plus 4 kilometers plus 4 kilometers. It will give 10 kilometers. So this is the initial position from where the object started moving, and this is the final position where it reached after traveling a certain distance. Let us discuss displacement. Displacement, on the other hand, is the shortest distance between the initial and the final position of a moving body. That means it is the shortest distance, and to get the shortest distance we can just join the 2 points with a straight line. So the distance from A to B, let us suppose it is 6 kilometers. Then 6 kilometers will be its displacement. So distance is the total length of the path, and displacement is just the distance between the initial and final position. Let us take another example. It will be easier for you to understand. If a point starts from point P, if an object starts from point P, travels a certain distance and reaches the point Q, and then again it comes back to the point P, then its distance will be, in this case, distance, which is denoted by capital S, is 5 going and 5 coming. That will be 5 plus 5, it will give us 10 meters. But if I will take the displacement, which is denoted by vector S, it will be initial, final. Both points are same, so it has no distance between them. That means 0. Vector quantities are represented with an arrow mark on top of them, while the scalar quantities are can be denoted simply. Let us take one more example. If an object starts moving from a point A, reaches to a point B, then to a point C, then to a point D. If this is 2 meters, 3 meters, and this is also 2 meters, then here distance is 2 plus 3 plus 2, it is 7 meters, and displacement is from here to here, it will be 3 meters. So from this we can conclude that if a body takes a round trip, whatever be the shape, then its displacement will be 0. But if a body has traveled some distance, have been in motion, then definitely its distance will never be 0. But displacement may be 0 or may be greater. One more case I would like to discuss. If an object travels from a point A to a B in a straight line, then its distance and displacement both will be equal. Their magnitude will be equal because the shortest distance is the distance between A and B, since it has traveled a straight path. So here comes your homework question. Differentiate between distance and displacement. Keep learning, keep growing. Have a nice day.